Today we're going to be looking at equations and figuring out functions. So the name of today's lesson is Evaluate a Function Given a Formula. So here's f of x equals 3x squared minus 4. Again, we talk about the fact this is kind of like y. And we talk about the fact that evaluate means to figure out. I want to kind of go in some preliminary stuff here. Just remember that a variable just means some number, okay? Usually just represents a real number, and then here we have plus 1. So I know it's kind of basic. Now what happens when you're evaluating functions is, we talked about in the last lesson, when you plug something in, you put it in parentheses, and what you're plugging in is your input. So for example, x becomes 8 in this example. We're plugging in 8, and then we're still adding that same 1 that we had before, and we get 9 back. So 9 would be your output, 8 would be what you plug in. We could do the same thing with, for example, 2. You're plugging in 2, okay, and then you add 1 and you get 3 back. So 2 would be your input, 3 would be your output. We could also plug in a negative number, okay. So we plug in negative 7 and we add 1, that'd be negative 6. So negative 7 would be your input, negative 6 is your output. What I want you to see is that the number that you plug in is the x value. The number that comes back out, or your output, is your y value. Okay, so what? I mean, in general, basically, the number you plug in is your input, x. The number that comes out is your output. Very simple. And most of the time we call it f, or f of x. You can call it g or h or whatever, but most of the time it's f. The way that we write that, which we're going to kind of show a little bit more detail here, is that we plug it in parentheses. Okay, in this case the function is x plus 1. We're plugging in 8, we add 1, we get 9 back, so f equals 9. Okay, we can do the same thing with 2, f equals 3. We can do the same thing with negative 7. We get negative 6 back. But here's the thing. We want to be able to show what we're plugging in, and this is exactly why we have function notation. Okay, notice before we just had f, and we plugged in negative 7, but why did we plug in negative 7? Okay, so in other words, why did it just automatically plug in negative 7? Well, if we stipulate, for example, f of 5, okay, and we know that the function is f of x, it only makes sense then that we're plugging in 5 for x. So for example, the question said, what is f of 5? You would immediately know, well, I'm dealing with f of x, and it said f of 5, so every time there's an x, I'm going to replace it with 5. Therefore, when we write the final answer, we can write f of 5 equals 6. Before, for example, this example, we just have f equals negative 6, and that doesn't really tell us what we plugged in. This is precisely why we have function notation. We have the parentheses so that we can put the number we're plugging into the parentheses and we get the number back. We typically used y in Algebra and Algebra 2. Now we're using f because f means function. Some students ask me, well, could you use y? Could you say like y of 5, like a y here? Of course. But when you get to pre-calc and math analysis and stuff, you normally just resort to f. It's just the way it is. Alright, so let's look at another example. What if we want to figure out f of negative 9? Well, we just plug in negative 9 for x, add 1, we get negative 8. So f of negative 9 equals negative 8. We could do the same thing for a decimal. We could plug in 1.5, f of 1.5. You'd plug in a 1.5 for x, add 1, you get 2.5, so f of 1.5 equals 2.5. What I want you to see, and this is something that took me forever to realize, f of x this is the way you read it, okay? You do not say f times x. Now, I'm saying that because it's something in parentheses, and I know you've been taught if you have something next to parentheses, you multiply. Not in this case. For f of x, it means f of x. It does not mean f times x. It means you're plugging in an x value and you're getting a y value back. So, as a recap, x is what you plug in. It's your input. It's your independent variable, like you learn in science. F of x is what comes out. It's your output. It's your dependent variable. It depends on the number you plug in, which is x. Let's look at example 1. We have f of x equals 3x, evaluate f of 2. And now you're starting to see, okay, this is why we have parentheses, because now every time there's an x, we're just going to replace it with 2. This is very important and very fundamental. Okay, why does it mean that? Because instead of an x, there is a 2. Okay, so that means every time there is an x, we're going to put a 2 in place of it. That's exactly what step 1 is. Okay, it says replace x with the number input. So every time there's an x, we're just going to replace it with 2. And that way we can figure out what f of 2 is. We normally put that on the left. What we're trying to figure out is what we put on the right. So now all we have to do is do 3 times 2. I always put parentheses around it. I can't stress that enough. So then we just figure it out, solve basically. 3 times 2 is 6, and that's the answer. F of 2 equals 6. It's that simple. Example 2 says f of x equals 2x squared minus x. Figure out what f of negative 4 is. Notice there's 2 x's here on the right, so we're going to have to replace them both with negative 4. And it says replace x with the number input. So every time there's an x, I'm just going to replace it with negative 4, and that will tell us what f of negative 4 is equal to. Okay, so let's do some order of operations. We want to, I guess I kind of went out of the order of operations. We should technically square that first, but we can do this first since it's separate. Minus minus becomes plus 4. Negative 4 squared is positive 16. Remember, you want to do the exponent first before you multiply in PEMDAS. And then now we can multiply the 2 times the 16, which is 32. 32 plus 4 is 36. Therefore, f of negative 4 equals 36. It's that simple. We started with 2 x values. We plugged in negative 4, and we figured it out to be 36. So therefore, f of negative 4 equals 36. We solved it. We're done with step 2, and we're done with the problem. Example number 3. F of x equals x squared. Evaluate f of x minus y and multiply out. Well, f of x minus y means every time there's an x, we're going to replace it with x minus y. This one's a little confusing, but you can evaluate a function without having to plug in a number. Sometimes you can plug in a variable. Okay, so every time there's an x, we're replacing it with x minus y because the problem says f of x minus y. Okay, so then it's x minus y squared. Remember, you can't just distribute the 2 to the x and the y. You have to multiply x minus y times itself, which I'm showing you here. So when you square something, you multiply it by itself. We're going to FOIL. I'm not going to go into too much detail about that. If you have any questions, let me know. Take the x multiplied times the x minus y. Take the minus y multiplied by the x minus y, and then simplify. Final answer, x squared minus 2xy plus y squared. That means f of x minus y is equal to that. So you can plug in variables, and you can certainly simplify it to, or not really simplify in this case, you're expanding because that's what the directions said, but you can multiply it out to get an answer. You don't just have to plug a number in when you're evaluating a function. Example number 4. We're going to plug in a variable again. It says g of y equals 10x cubed over y. And since a little confusing, but it says evaluate g of negative 15x to the 7th. Well, guess what? Every time there's a y, we're going to replace it with negative 15x to the 7th. So y can actually also be an input. All you should be noticing is that if whatever the variable in the parenthesis is here is what you're going to be replacing with here. Simple. This is going to go into that, which means it's also going to go into that y. So y can be an input sometimes, rarely, but just for the sake of example. Okay, so replace y with the number input. You're replacing whatever this variable is in the parentheses with whatever you're plugging in. It's that simple. So we're going to replace it with negative 15x to the 7th, and now we just have to simplify this. This is dividing monomials, by the way. So 10 over negative 15 reduces to negative 2/3, and then you basically take the bigger exponent and subtract the smaller one, so we get x to the 4th on the bottom. So final answer, g of negative 15x to the 7th equals negative 2 over 3x to the 4th. Let's do one more example. Actually, I think we have 2 or 3 more examples. We have f of x equals the 4th root of 3 plus 2x. We're evaluating f of negative 2, so every time there's an x, we're plugging in negative 2. I always put it around parentheses, always, always, always. So that's what we did there. Every time there's a x, we're going to replace with negative 2. And then we're going to do what's inside the radical first, and then hopefully apply the 4th root to that. So what's 2 times negative 2? Step 2 is to solve. 2 times negative 2 is minus 4. 3 minus 4 is negative 1. Well, what's the 4th root of negative 1? you can't take an even root of a negative number, and so therefore this particular example, f of -2 is undefined. So sometimes when you're evaluating something and you plug it in, you might not get something back, and therefore it's undefined. Does it make it not a function? No. Okay, because this particular function has one output for every input. It doesn't have to have an output for every input. It's still a function. Example number 6. We're going to do a practical example together. Following is a formula for a nightly temperature, a function of cloud coverage, hours in a day. Okay, so H is your, how many hours of cloud coverage there are. You plug that in and it's going to give you the nightly temperature. What would be the nightly temperature with 8 hours of cloud coverage? Well, guess what? All we have to do is replace H with 8, and that will give us our nightly temperature. This is a more practical example. So we're going to plug in 8 for H. Okay, every time there's an H, we're going to plug in 8, and we're going to figure that out. So it's 100 divided by 8 plus 10, which works out to 12.5. 100 over 8 is 12.5 plus 10, 22.5. So T of 8, remember 8 is what you're plugging in hours, gives you 22.5. After 8 hours of cloud coverage, it will be 22.5 degrees at nighttime. Pretty cool problem. Not sure if this is Fahrenheit or Celsius, but anyways, basically you've got an input and you get an output. Your input is the hours of cloud coverage. Your output is the nightly temperature. That, in essence, is functions when you're plugging them into formulas, and if you have any other questions, let me know.